Let us look at question number 41 now. The magnitude of crystal field splitting energy delta T in tetrahedral complexes is less than that in octahedral complexes. So consider the following statements. S1. There are 4 ligands instead of 6, so the ligand field is only 2/3 the size, and hence the ligand field splitting is also 2/3 the size. And looking at statement 2. The direction of orbitals does not coincide with the direction of the ligands. This reduces the crystal field splitting by a roughly further 2/3. So students, we know that delta T is roughly equal to 4/9 delta naught when we are dealing with the same metal ion and the same ligands. So the examiner has divided this factor of 4/9 into two parts and attempts to explain the factor of 4/9 in terms of two 2/3s. So in the first statement, he says that there are 4 ligands instead of 6. So ligand field splitting is also 2/3 the size. This statement is correct. In octahedral we have 6, whereas in tetrahedral we have 4 ligands. So the ratio is 4/6, which is equal to 2/3. So the first statement is correct. Looking at statement 2 now, the direction of orbitals does not coincide with the direction of ligands. This reduces the crystal field splitting by roughly a further 2/3. So students, this statement is also correct. We know that in an octahedral field, the EG orbitals are directly facing the incoming ligands, whereas the T2G electrons are not. But in an tetrahedral field, we know that neither EG nor T2G directly face the incoming ligands. Okay, there is more repulsion felt by the T2 electrons as direction of approach of ligands is closer to them as compared to the EG electrons. But still, since the T2 orbitals do not directly face the incoming ligand, the splitting in this case is less, which leads to a crystal field splitting of roughly 2/3 than that in the octahedral field. So students, the second statement is also correct, and we have to mark option 3 as the correct answer to our question. Let us look at question number 42. A metal cation gives a black colored precipitate with H2S in presence of NH4OH and NH4Cl buffer. This metal cations forms a yellow precipitate with potassium cyanide, which turns into white and finally dissolves in the excess of reagent. The metal cation forms a green colored precipitate with carbonate ion. We have to identify the green colored precipitate. So students, the given cation in the question is copper. So copper gives a black precipitate of CuS. When the metal cation is allowed to react with KCN, it forms CuCN twice, which is a yellow colored precipitate, which on standing turns into Cu2CN2 and liberates cyanogen gas. So this is white in color. And if an excess of KCN is further added, it forms a complex CuCN 4,3 negative. Now, when copper reacts with carbonate ions in the solution, it forms a green colored precipitate of basic cupric carbonate. So the correct compound is given in option number 4, and we have to mark option 4 as the correct answer to our question. Looking at question number 43 now, consider the following statements and select the incorrect statement out of the following. Cr3 plus and Ni2 plus both form green precipitates with NaOH. This statement is correct. CrOH whole thrice and NiOH whole twice are both green in color. But the precipitate of the former dissolve in excess reagent, whereas that of the later does not. This is correct. NiOH whole twice does not dissolve in excess of OH minus, whereas CrOH whole thrice, when dissolved in excess, it forms a complex CrOH whole 4 negative. So statement 1 is correct. Let us look at statement 2 now. Ag plus and Hg plus both form brownish black precipitate with NaOH. This statement is also correct, students. Ag plus and Hg plus, they both form their oxides on reaction with OH minus ions. So Ag forms Ag2O, whereas Hg forms Hg2O. Both of them are brownish black in color. Okay. So the second statement is also correct. Let us look at option 3. Fe2 plus and Fe3 plus ions form dirty green and reddish brown colored precipitate with NaOH, neither of which dissolves in the excess of the reagent. This statement is also correct. FeOH whole twice is dirty green, whereas FeOH whole thrice is reddish brown. And both these species do not dissolve in excess of OH minus. Let us look at the fourth option now. Al3 plus and zinc 2 plus both form gelatinous white precipitate. This is correct. We have gelatinous white precipitate of aluminum hydroxide and ZnOH whole twice. But the precipitate of the former dissolves in excess of reagent, but that of the latter does not. Students, this statement is incorrect. Both AlOH whole thrice and ZnOH whole twice dissolve in excess of the reagent, forming aluminate, AlOH whole 4 minus, and zincate, ZnOH whole 4 2 minus, respectively. So the fourth statement is incorrect, and we have to mark option 4 as the correct answer to question number 43. Let us look at the next question. Question 44. Let the number of geometrical isomers of complexes Ma4B2, Ma4BC, and Ma3B3 be X, Y, and Z respectively, then the correct option among the following is. So if we talk about Ma4B2, students, this is going to have two geometrical isomers, in which first will be B cis B and the second will be B trans B. Okay. And rest ligands will arrange themselves accordingly. So it has two geometrical isomers. So X is equal to 2. So if we look about the second complex, Ma4BC, students, this also has two geometrical isomers, which is B cis C and B trans C, and the rest ligands will arrange themselves accordingly. So this gives us a value of Y equal to 2 again. Now if we talk about the third complex, which is Ma3B3, so we know that this has two geometrical isomers, which are meridional and facial. So the value of Z is also again equal to 2. So we can see that the value of X is equal to Y is equal to Z, which is given correctly in option 1. So we have to mark option 1 as the correct answer to our question. Let us look at the next question. Question number 45. Extraction of Ag or Au is done by the cyanide process and the refined form of metals are obtained at the end. So some processes are mentioned below: leaching, reduction, and complexation. Out of the given processes, the ones which are used in the cyanide process is R. So if we talk about the cyanide process, we have a metal M, which is allowed to get oxidized in presence of air and leach with cyanide ions to form a complex MCN whole twice negative. Okay. And once the metal is leached out from the solid state into the solution, it is then filtered off and the filtrate is further allowed to react with zinc, where reduction takes place. Zinc is more reactive than either Ag or Au, and it reduces the Ag plus or Au plus ions into metallic Ag or Au, and itself gets oxidized into zinc 2 plus ions, and it forms a complex with the cyanide ions present. So it forms ZnCN4 2 negative. So students, we can see that leaching is also taking place in this reaction, in which the M is first converted into M plus, and then it is complex with Cn minus to form MCN whole twice negative. So students, all three of these processes takes place during the cyanide process, and we have to mark option 4 as the correct answer to our question.